Good morning, my dear students. Now, there is a very important explanation in this video clip that is said to be Einstein explanation of photoelectric effect. Now, in the experimental results, that is in experimental result, there are different results now here. That is one is the photoelectric effect is instantaneous process. Second one is there is a minimum frequency of incident light. Below that frequency, there is no emission of photoelectrons. That is called threshold frequency. Then maximum wavelength of the incident light. Above that wavelength, there is no emission of photoelectrons. That is called threshold wavelength. Then one more that is a result. The photoelectric current is directly proportional to the frequency of the intensity of the incident light. Then one more result, that is the kinetic energy of the photoelectrons is directly proportional to the frequency of the incident radiation. These two now results are study made. But in the case of experimental setup, or said to be photoelectric effect experiment, actually the photon or light energy is incident on that photosensitive material. Within that material, what happens? That point is cannot explain in the case of experimental study. Then Einstein adopted this theory to the light, and he explained about the photoelectric effect. What is takes place? It means when the photon is incident on the photosensitive material, what happens? What is the mechanism takes place inside the material? That would explain by Einstein. Therefore, there is Einstein explanation of photoelectric effect. Whatever he give the equation, that is said to be Einstein photoelectric equation. Okay. Now, see here. According to that Einstein explanation, when the photon, according to quantum theory, that is said to be photon, light is incident on this one. The photon with the frequency, suppose you say to be nu, energy is equal to h nu, photon. Now it is incident on the photosensitive material. That photon is interact with the material. Interact with the material means, photosensitive material means, whatever the atoms inside the material that absorb this energy when it is interact. Once it absorbs this energy, suppose that usually this is the 10 electron volt, suppose we say to be incident energy 10 electron volt. Then it absorbs the energy, then it is overcome from the attractive force of the nucleus, and then electrons are overcome from this attractive force, then emit, and it is moved with the kinetic energy. ಏನು ಮಾಡುತ್ತೆ ಫೋಟಾನ್ ಇನ್ಸಿಡೆಂಟ್ ಆದ ತಕ್ಷಣ ಇಂಟರಾಕ್ಟ್ ಆಗುತ್ತೆ ಮೆಟಲ್ ಜೊತೆ. ಒನ್ಸ್ ಮೆಟಲ್ ಜೊತೆ ಇಂಟರಾಕ್ಟ್ ಆದಾಗ ಏನಾಗುತ್ತೆ, ಆ ಆಟಮ್ ಎಲೆಕ್ಟ್ರಾನ್ ಇದು ಎನರ್ಜಿ ಅಬ್ಸರ್ವ್ ಮಾಡುತ್ತೆ. ಅಬ್ಸರ್ವ್ ಆದ್ಮೇಲೆ ಆ ಎಲೆಕ್ಟ್ರಾನ್ ಎಮಿಟ್ ಆಗಿ ಅಥವಾ ಫೋಟೋ ಎಲೆಕ್ಟ್ರಾನ್ ಎಮಿಟ್ ಆಗಿ ಅದು ಮೂವ್ ಆಗುತ್ತಾ, ಅದು ವೆಲಾಸಿಟಿ ಇರುತ್ತೆ, ಅವಾಗ ಏನಿರುತ್ತೆ ಕೈನೆಟಿಕ್ ಎನರ್ಜಿ ಇರುತ್ತೆ. ದಿಸ್ ಇಸ್ 1/2 mv². m is the mass of the photoelectron, v is the velocity of the photoelectron. Suppose here the one more important point here, already Hall versus and Leonard observations, that is the existence of the threshold frequency. Means the minimum frequency is required, minimum energy required. Now, whatever the minimum energy is required to emit the photoelectron from the surface of the photosensitive material, that is called work function. That is called work function. ಅದಕ್ಕೆ ನಾವೇನಂತ ಹೇಳ್ತೀವಿ, work function ಅಂತ ಹೇಳ್ತಾರೆ. This is measured in terms of electron volt. What is electron volt? Electron volt is the electron gain the energy when it is accelerated to the potential difference of 1 volt, that is called 1 electron volt. That is 1 electron volt, that is equal to 1.6 into 10 to the power of -19 joule. That is the 1 electron volt. Now it is a work function. It is the minimum energy is required to remove the electron or emit the electron or escape the electron from the photosensitive material. That is called work function. that work function is represented by pi. Suppose its work function that is said to be 6 electron volt. 6 electron volt is the work function. This much amount of energy is required. That energy that is said to be h nu naught. It means threshold frequency. Incident photon energy, minimum frequency required, minimum energy is required, minimum frequency required, it means threshold frequency, minimum energy required, it means work function, that is h nu naught. And it is a 10 electron volt is incident. For example, you have to take here. On the example, no, 6 electron volt is the work function. It means 6 electron volt is required to that is emit the electron. And what is the remaining energy? That is said to be in the form of kinetic energy. That is the 4 electron volt. That is only example for one particular material. This is one example. This is the 10 electron volt is the photon energy, incident photon energy, and a photosensitive material. The work function is the amount of energy required to emit the electron. That is 6 electron volt, and remaining 4 electron volt energy is in the form of kinetic energy. Now, in this energy, very small energy, that particle energy is measured in electron volt, but not joule. Because very less. Very less energy, therefore it is measured in terms of electron volt. Then according to Einstein explanation, you apply the law of conservation of energy, then you obtain the expression for this one. Now incident photon energy E is equal to h nu. Here h is the Planck constant, its value is 6.625 into 10 to the power of minus 34 joule second. Now nu is the frequency of light, incident light. Frequency of the incident light, or said to be incident photon. Then work function is equal to pi h nu. It is a minimum energy is required. Minimum energy is required to emit the electron. Now here incident photon energy should be greater than the work function. Photoelectric effect photoelectrons emit incident photon energy work function kinta ಹೆಚ್ಚಿರಬೇಕು. ಅದರ ಅರ್ಥ h nu is greater than h nu naught. It means nu greater than nu naught. Whatever the threshold frequency for the photosensitive material, the incident photon frequency should be greater than the threshold frequency. At that time, it is the incident photon energy is greater than the work function. At that time, the photoelectrons are emitted. The photosensitive material shows the photoelectric effect. Okay. By law of conservation of energy, whatever the incident photon energy is equal to sum of the work function and the kinetic energy. The incident photon energy is equal to work function and kinetic energy of the photoelectron. Now that is E is equal to this is said to be pi h nu naught plus k. And this one and this one, they are said to be Einstein photoelectric equation. Said to be, it is very important. This is asked in the examination for 3 marks repeatedly. Okay, this is the Einstein photoelectric equation. Okay, that is E is equal to h nu naught plus 1 by 2 m square. Question number 4. With the help of this expression, this kinetic energy E is equal to minus pi. Now this is said to be incident photon energy. This is said to be work function. Now kinetic energy depends on incident photon energy and the work function. It means it is a dependent. It is independent. Now k is equal to h nu minus pi. Why? Now it is in the form of pi is equal to mx minus c. In minus 1 is mx minus c. Plus is mx plus c. Now you draw the graph. What do you want to draw the graph? You draw the graph kinetic energy of the photoelectrons along y-axis. Now incident photon frequency along x-axis. Incident photon frequency along x-axis. Okay. Now you draw the graph here. You draw the graph here. Now you obtain this one. This is what the mu naught frequency. Will intercept bರುತ್ತೆ. ಆಮೇಲೆ ನೆಗೆಟಿವ್ y-axis ನೋಡಿದ್ರೆ ಇಲ್ಲಿ ಬರುತ್ತೆ, intercept ಬರುತ್ತೆ. ಇಲ್ಲೇನದಲ್ಲ OP. This OP indicate the threshold frequency. This much OP indicates that is said to be threshold frequency. Yes. Now OQ indicate that is the work function. That is the h nu naught work function. Represent the work function. With the help of this graph, you got the threshold frequency. You got the work function. Okay. Now you take the slope. Slope is equal to AC by BC. You got here m is the slope. Slope indicate h is that you got the slope of this kinetic energy versus frequency graph. Whatever you got the straight line, slope of this and will give the Planck constant. As you said, we experimental study. You easily draw the graph here. You got the threshold frequency and work function. The value of that is said to be Planck constant. It is with the help of that is a graph kinetic energy versus the frequency. Thank you. Morning, my dear students. In a previous video clip, already you know about that is Einstein explanation of photoelectric effect and its equation. Now that is the photoelectric equation. E is equal to pi plus k, is said to be kinetic energy of the photoelectron. E is equal to h nu naught plus k. H nu is equal to h nu naught plus 1 by 2 m square. You write any equation, 3, 4, 5, all the equations are photoelectric equation. Now discuss a few points about this one with the help of this one. Few points about this one. That is said to be h nu is equal to h nu naught plus kinetic energy. Fine. Now discuss the few points. What happens now in incident? You vary the frequency of the incident. Like what happens now? Now first one, if nu is greater than nu naught, at that time what you got? H nu is greater than h nu naught. It is just there. It birth. According to this expression, kinetic energy is equal to what you got here? H nu minus h nu naught. Now kinetic energy, it becomes what you say positive. Kinetic energy ಬರುತ್ತೆ ಇದಕ್ಕಿಂತ ಹೆಚ್ಚಿತ್ತಂದ್ರೆ kinetic energy positive. What is the meaning of this one? The incident frequency of light or a photon is greater than the threshold frequency. Then the photoelectrons are emitted. They are moved the certain kinetic energy. That your kinetic energy got positive. No. See, if you discuss this point, if nu is equal to nu naught. Now whatever the incident photon frequency is equal to threshold frequency, at that time h nu is equal to h nu naught. At that time this kinetic energy becomes zero. Zero. If the incident frequency of light is equal to the threshold frequency, the photoelectrons are just emitted but not moves. It indicates just emit. ಇಲ್ಲಿ emit ಆಗುತ್ತೆ, ಇಲ್ಲಿ ನಿಲ್ಲುತ್ತೆ, but movement ಅಲ್ಲ. ಅದರ ಅರ್ಥ velocity zero ಇರುತ್ತದೆ. There is no movement of the photoelectrons. Move ಆಗಲ್ಲ. And then this becomes if nu is less than nu naught. Incident frequency of light less than the threshold frequency. At that time, incident photon energy is less than the, that is said to be work function. At that time, kinetic energy you got negative. Kinetic energy you got negative. It indicates what is the meaning of this one. There is no photoelectric effect takes place. Agade illa. There is no emission of the photoelectrons. Whatever the value of this negative value, that indicates that much amount of energy is required to just emit the electron. If for example ಇದು -2 electron volt ಬಂತು ಅಂತ ತಿಳ್ಕೊ, ಫೋಟೋ ಎಲೆಕ್ಟ್ರಾನ್ ಎಮಿಟ್ ಆಗ್ಲಿಕ್ಕೆ ಇನ್ನೂ ಅಂತ ಅಷ್ಟು ಎನರ್ಜಿ ಬೇಕಾಗ್ಯದ ಅಂತ ಏನ್ ಮಾಡ್ತದ ಮೀನಿಂಗ್ ಕೊಡ್ತದ. ಇನ್ನು ಇಷ್ಟು ಬೇಕಾಗ್ಯದ, ಇನ್ನು ಫೋಟೋ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಎಮಿಟ್ ಆಗ್ತದೆ ಇಷ್ಟು ಬೇಕಾಗಿದೆ ಅನ್ನೋದನ್ನ ಮೀನಿಂಗ್ ಕೊಡ್ತದ. ದಿಸ್ ಇಸ್ discuss about the Einstein photoelectric equation, about that is said to be in a different condition. If incident frequency of light is greater than threshold frequency, if incident frequency of light is equal to the threshold frequency, if the incident photon frequency is less than the threshold frequency, discuss the few points. This is the Einstein explanation of the photoelectric effect. Once again repeat, Einstein explained the photoelectric effect with the help of that is a light, and that is said to be photon. Photon you have to take here. He adopted that theory to the photoelectric effect, and then incident packets of energies are said to be photons. Now, what are the properties of the photons? I will discuss in the next video clip. Thank you.